This is my old downhill bike, and in this video we'll convert it into a 5000 watts electric dirt bike, capable of reaching 70 plus km per hour. The bike I got for this build is a 2009 Banshee Scythe that I purchased second-hand for €500. To achieve the performance I'm after, I reached out to Kirbebike, and they were happy to help with this project by providing this beast of a motor capable of doing 70 plus km per hour, with a peak power of more than 40,000 watts. Thanks again to Kirbebike for providing this motor. You can find links to it in the description below. The build can start by removing the rear wheel from the bike and installing the tire and inner tube to the new wheel. Despite its age, this bike already comes with a through axle, which isn't really ideal for a conversion like this, since the motor is designed to slot directly into open dropouts, and there is no way to mount it to a through axle frame without permanently modifying it. To solve this issue, I designed a couple of adapters that interface perfectly with the frame dropouts and get screwed very securely in place with a bunch of already existing bolts on each side. This solution allows for an extremely strong and secure connection between the motor and the frame, providing thick open dropouts that eliminate the need of a torque arm. These adapters were custom made out of chrome-plated 4140 steel by PCBWay, which kindly sponsored this video. PCBWay is my go-to website when it comes to high-quality on-demand manufacturing. They offer a wide range of services from PCB making to plastic and metal 3D printing, injection molding, CNC machining and more. They provide very fast turnaround times and low prices, so check them out at the link below. With the dropouts sorted, we can mount the motor and move on working on the controller. For that, I've 3D printed a waterproof enclosure that allows to pass all the necessary cables through these waterproof connectors. I wanted to make something as reliable as the motor, that could be safely washed with a hose or also a pressure washer, so I made extra sure to make everything watertight. With the cable glands in place, I secured it to the frame using a couple of zip ties and moved on mounting the last few components to the bike, such as a fresh set of handlebars, the full twist throttle, the regen brake and grips. The controller will be mounted to an aluminum plate using double-sided thermal tape, with a heatsink glued to the opposite side. This will allow to efficiently dissipate the heat generated by the controller while still maintaining water tightness. At this point, all the wires can be connected to the controller before closing the box, also applying some silicone to ensure a tight seal. Moving on to the battery, I purchased this 60 volts 20 Ah unit, which is the biggest battery I could safely fit in a backpack, considering its reasonable weight of just 6 kg and the size of 300 by 180 by 70 mm. Having now tested it, I can confirm that the 20 Ah of capacity can provide anything between 50 to 80 km of range on flat ground on throttle only, and about 30 km of off-road mountain riding, with about 1000 meters of elevation gain, which in my opinion isn't bad at all. One thing that helps a lot with the range is the ability to activate regenerative braking, which works extremely well, gaining back as much as 50% of the power consumed climbing a hill when coming back down it. Charging batteries of this size could potentially be quite dangerous, due to the high energy that they carry. Fortunately, there are products like this charger enhancer by PCBWay, a small and nice looking device that can make charging batteries safe, giving an extra control layer between the charger and the battery, cutting off power if anything happens to go wrong. This device can monitor in real time the charging status by showing how much power the charger is pushing into the battery, how many ampere hours and volts. You can monitor the battery capacity over time to see if it's degrading, and you can also set safety current and voltage limits to be extra sure that the battery will not overcharge. Thanks to PCBWay for caring for my safety and providing this charger enhancer for this video. You can find a link to it in the description below. As I already mentioned, the battery needs to be fitted inside the backpack, mainly due to the inability to fit it anywhere else on the bike frame, because of its geometry, suspension linkages and its quite small size. This is not a big issue because it keeps the bike lighter, more agile and maneuverable. Also, the battery is not extremely heavy, and as long as it is fitted into a tight mountain bike specific backpack, it ended up being actually quite comfortable to ride with. With also the battery sorted, this absolute beast of an e-bike is finished, and looking very much like a normal mountain bike. So much so that I've shown some pictures of it to my friends, and literally no one thought it was electric, let alone thinking that it has more than 4000 watts of peak power and the ability to reach 70 km per hour. This is in fact what I really like about this build. I think that you cannot get more stealth than this. At first glance it's just a bike. Now that the bike is finished, the only thing left to do is to test it. I was immediately impressed with the performance of this vehicle. It doesn't have a very impressive torque, being hub-driven, but the torque is constant all the way through the speed range. The max speed on flat ground is around 70 km per hour, and the max power I measured was 4800 watts. This value is limited not by the motor, but by the battery, which can only output a maximum of 60 amps at 67 volts. The phase current of the motor is much higher, limited to 200 amps, giving just enough torque to be able to climb off-road trails as long as they are not super steep. Still, that's quite impressive in my opinion, especially for a DIY build, and I honestly didn't think that climbing trails would have been possible. Climbing on the road has been even more impressive, reaching 50 km per hour on this mountain road, and trust me, it is very steep. To give you a rough idea, my 50cc scooter reaches about 40 km per hour on this same climb. Not everything is perfect. In fact, since the motor is rated at 60 amps, and I'm pushing more than 3 times of that, the motor overheats quite a bit, especially when climbing trails at low speed. Who would have guessed? To help with that, I got some ferrofluid that I injected into the motor to bridge the gap between the rotor and the stator, improving thermal conductivity quite a bit. This helped surprisingly by more than doubling the heat dissipation capabilities of the motor, keeping the temps way lower than before. Another major problem is that the rear wheel is so heavy that I kept getting punctures. To solve that, I decided to go tubeless with an insert, which meant swapping the rim with a tubeless compatible one. This was a huge pain, but fortunately it ended up completely fixing the puncture problem. With also that sorted, this project is truly finished. Every time I take this bike for a ride, I'm always more impressed than before. I would have never expected it to have this much power and to be this fun off-road. It is amazing on slightly uphill or flat trails, allowing you to reach scary speeds. The only unsolvable problem is the weight distribution, which is completely crap, with half of the weight of the bike being located in the rear wheel, as unsprung mass, making the bike ride very badly downhill or on rough trails. Obviously, some trade-offs need to be made when building around an already existing frame, but that's fine considering all the other nice aspects of this bike. Building it made me realize how much fun a proper electric dirt bike can really be, and in the future I will definitely build something comparable to a Talaria or a Suron. So that's it for this video. Consider subscribing if you liked it, and thanks again to PCBWay, Kirbebike and PID Zoom for supporting this project. I will see you in the next one.